In Learning Objective C, we're going to determine if events are independent or dependent. We're going to talk about events being independent of each other. If two events are independent of each other, means one will not impact the outcome of the other. If they are not independent, means they are dependent on each other and they will impact each other. Well, there's a test that we do to see if two events are independent. What you have to do is find the probability of A and B happening at the exact same time. Notice this is one p-value, so it's one fraction you're going to find. And then you're going to find the separate probabilities. You'll find the probability of A, its fraction answer, and the probability of B, its fraction answer. If these two fractions, when you multiply them together, equal the same as this side's probability, then it means events A and events B are independent from each other, and the outcome of one will not impact the other. So let's take a look at one example here. We have a spinner shown and used at a carnival game right here with 6 sectors, and it's assumed to be fair, and the probability of landing on each sector is the same, so 1/6. If the spinner lands on the edge, it doesn't count. This game consists of doing 2 spins. You win if the first one stops on an even number and the second spin stops on a multiple of 3. What's the probability of winning? So let's first think about it. We have spin 1 and spin 2. The possible number of outcomes would be 6 options for the first spin, 6 for the next, because you can have repeats, 36 outcomes. So what you see here is a little grid they've put together. Spin 1 can be 1 through 6. Spin 2 can be 1 through 6, so every dot here represents one of the 36 outcomes. So let me show you how to actually use this formula right here. Let's first start by finding the probability of A and B happening together. So I'm going to write the probability. Event A is that the first stops on an even, and B is the second stops on a multiple of 3. So I want to find the first is even. Remember this notation, that means and, so I'm going to put and. The second, I'm just going to put as a multiple of 3. So to find that, I'm just going to actually look over at this grid, find where the first ones are even, which are going to be here and here. So the first one has to be even, so it could be any one of these 3 rows, but at the same time, the second has to be a multiple of 3. So that would be a 3 or a 6. So the ones that make it would be this, those 3 here, and these 3 here. So the probability that both the first is an even and the second is a multiple of 3 is going to be 6 out of 36. Now let's switch gears and look at them separately. Let's just find the probability of A and then times it by the probability of B. So the probability of A happening, and in this case it's the first spin is an even, so first is even. If you do a spinner just once, what's the probability the first spin is even? That would be either a 2, 4, or a 6, so that would be 3 out of 6. Okay. Probability of B is the probability that the second is a multiple of 3. So if we do the second spin, multiple of 3 would either be the 3 or the 6, so that would be 2 out of 6. So now what I'm going to do is take the probability of A and times it by the probability of B. That's 3 out of 6 times 2 out of 6, and that gives us 6 out of 36. Now all you have to do is compare these two probabilities, this one and this one. They are the same, therefore these events are considered independent of one another, which means the outcome on the first event, that the first stops on an even, will not impact the second event about the second spin stopping on a multiple of 3. Now, as you do the math to confirm it, you might be able to think logically, and if you read this scenario, it will probably seem logical that these events will not impact each other, so you probably will think it's independent. However, you must do the math to prove these two answers are the same. Let's look at another one, and we jot down the formula we're going to do. So here it is. Again, to see if two events are independent from each other, let's find this single probability by itself, then these two individual ones and multiply them together. If the two sides equal, it means independence. If they don't equal, then there's some dependency going on. Okay, so we're going to go back to our two spinners from our previous example. In this case, they're going to switch it. We're going to keep event A, which was that the first spin is even. Now here they're changing B to be this. The sum of both spins is greater than 8. So I'll just jot that down right here. Sum of 2, I'll just put is greater than 8. Okay, so let's do the test. Now we do have our sample space again here of the 6 and 6, or all 36 outcomes. So first one is the probability of A and B both happening at the same time. So to do this, you have to count if both happen. So again, the first spin is even. We know is going to be these right here, the 2s, the 4s, or the 6s. But then for this here, at the same time, so you have to look at just the ones where the first spin is even, but at the same time, the sum of the two is greater than 8. And if we look at that, we're going to find that it'll happen here when it's 9. This one here is 8. And in this case, it looks like there's just going to be 6 events. So this would be 6 out of 36. Again, meet both of those requirements. So let's break it down to the second part right here. I'm going to find the probability of event A. Event A is the first is even. We know if we just do one spin, if the first is even, again, is 3 out of 6. Probability of event B, the sum of 2 spins is 8. So if we go back and look at this, we're looking at all of the spins, then it's greater than 8. So if we look at those, it's just going to be all of the ones here I just mark with the X. So here we have a 6-3, 6-4, 6-5. Here is a 5-4, 5-5, and so forth, a 4-5, and so forth. So there's 10 of those that meet that requirement. And that's out of a complete 36. Now we have to multiply these two together to find the probability of A times the probability of B. That'll be 3 times 6 times 10 over 36. I'm going to actually pull, why don't we do this? Take the 3 out of here, which is 1. 3 out of here would be 12. Just simplifying that one. I can do another simplification. Why don't I take a 2 out of here, and that would be 5. 2 out of here, and that would be 6. So if we multiply straight across, it looks like it's going to be 5 out of 36. So now you compare the two probabilities. This is the probability of A times the probability of B versus the probability of A and B together. They are not equal to each other, therefore these events have some dependency. So they are dependent events.